Number 1, the grade received in a class and the hours spent studying and doing homework. Well, if you think about it, if I increase my hours spent studying and doing homework, then you probably are going to increase your grade. So that would be a direct. The time to paint a house and the number of people painting. If we want to increase the time to paint a house, then we would decrease the number of people painting the house. So this is an example of an inverse situation. As one goes up, the other goes down. Okay. All right. So when you're dealing with tables, it's pretty easy. You just want to see if the numbers go up by a constant value, then what you do is you have a direct variation. Here we have, as we go from 2 to 3, we can see that it goes up by 5. So if I go up another unit, it needs to go up by 5, and that's what happened. If here I went up 2 units, so I should go up by 2 5s, which is obviously 10, and that's going to take us to 31. So this is right. We have direct variation, and our constant of variation is actually 5. Now here, it looks like as I go from one to the next, I'm doubling that value. And by multiplying by 2, that is not a constant of variation directly. And it's not going to be a constant of variation inversely, because this is something else. This is what's called a geometric sequence, and we haven't studied that. So this actually is neither. And you'll see why. This one's a little easier to see after we see what inverse is. Now in inverse, what's going to happen is I do see that 1 times 72 would give me 72, and 2 times 36 gives me 72. So if I multiply the x and the y together, that's actually the relationship that I get. Okay, all of these actually equal 72. So what that means is, when I multiply the x and the y coordinate, my constant of variation is 72. And so this is actually an inverse variation. So notice the difference between these guys. Okay. This is direct variation. Well, let's see. It would be, we added 5. Plus 5 plus 1, right? Yeah. There. So technically, actually, this should have been 10. Yeah. But anyways, so yeah, we don't want the plus 1 for direct variation. I'll fix that on the actual test. But you guys get the idea. Hopefully that typo won't be too big of a deal. Okay, so now we start with the easier stuff, and then we're going to work to the harder stuff. So here is just basic factoring. We simplify rational expression, and it's all about factoring. I can't stress that enough. You just look and see what you can take out, and you will find that that's all you got. Now I do see a 5 here. I know I can take a 5 out of there. Okay, so that the 5s can actually cancel out, and then our final answer is right there. Over here, factor. Just don't look at the whole thing as if you have to factor the whole thing. You have 2 separate things here, so you just want to take out what you can, use the x method all the time. Factors of 6 that add up to -7 is -6 and -1. If you're having a hard time with factoring, well, you know, Chapter 2 was it. We spent a lot of time on it, and yeah, I mean, I would just watch videos on how to factor, because we're kind of past that point. Factor is just kind of an assumed knowledge. This is where, you know, your past kind of comes to haunt you if you were losing a grip. So don't let that happen any further. Anyways, we don't need a pep talk now. Let's get a 3x out of this guy, so that we get x squared plus, let's see, 113x, and then 3 goes into 108, 36 times. And let's see, factors of 36 to 9 and 4. Okay, so that'll be plus 9 and plus 4. All right, again, I am factoring. I did see a GCF. Otherwise, I am not going to do the AC method with 3 times 108. That is way too large. So, well, I might have to if I have to, but if there's a GCF, then take it out. In fact, we don't really factor cubics unless we do grouping or we do GCF. Okay, that's all we pretty much got. All right, factors of this is going to be x minus 9 and x plus 4. Okay, so it looks like the x plus 4's cancel out, and we are left with a 3x, x plus 9, and x minus 9, which is going to be c. Okay, factoring again, I see a cubic, take out the x, and then I'm going to have an x minus 4, that'd be x minus 2, and x minus 2, and then this guy right here, x negative 8, that adds up to 7, would be 9 and 2, so that would be x plus 9 and x minus 2. So one of these will cancel, not both, but one of them. And, oh, wait a minute. They just wanted excluded values. Okay, well, I can't have a negative 9, and I can't have a positive 2, and that's it. Okay, I didn't even have to factor this, the numerator. I just factored the denominator. So that's cool. Looks like negative 9 and positive 2 are no-goes. I cannot plug them into this function, or else, well, this is an expression, but I would be dividing by 0. So if we were to graph this, that means that we would actually have 2 asymptotes. Okay, but we're not graphing those in algebra 2. All right, so here are the graphs for these guys. Remember, these are reciprocal functions, and we are looking at our first excluded value. Our one excluded value is negative 1. So let's go to negative 1. Okay, this is where our vertical asymptote is where this produces 0. Now this guy at negative 2 means I'm going to lift up the parent function here, and that is my new origin. So from here, I have to figure out which quadrants I'm in. Am I in the first and the third, or am I in the second and the fourth? They do a tag team like that. And I'm looking for x and y coordinates that will produce 2. So in this case, because it's positive, I'm going to be here and here. So positive 2 means I move over 1, go up 2, and then I move over 2, go up 1, because 2 times 1 is 2, and 1 times 2 is 2. Okay? All right, that's all you need. You just need to know how close are you to the asymptotes to do this by hand. Okay, and that's perfectly sufficient. All right, this guy's over here, and over here. We go over 2, down 1, go over 1, down 2. That's all you need. Get real close to the asymptote, and then go ahead and do that. All right, that's it. Now moving over here. We're going over 2 to negative 2. We will go up 1. And we want factors that multiply to give us 3. So we'll go over 1 up 3, and then over 3 up 1. That just gives us an idea of how close we are. This is positive, so we will be in these 2 quadrants. So I'm just going to do that. Okay. So notice the larger the number you have up here for our k, the farther away you get from the crosshairs of your asymptotes. Okay, oh man, these are pretty similar. All right, well, there'll be a balance of negative and positive. This guy goes to negative 1. Are they like the same? Oh, they're very, very similar. This guy just go, positive 2. Okay, sorry. This negative 2 should be down here. So, all right, let's do that, huh? So these answers are going to be flip-flopped. All right, so hopefully you weren't yelling at your screens. Okay, so let me double check here just to make sure. We go over 1 to the left and then up 2 for this guy. And then this guy, we went over to the left 1 and then down 2. So these guys should be switched. Okay, oops. Okay. So there you go. It was a nice mistake to make. This one right here, it looks like we're not moving to the left or right at all, so our asymptote will be on the y-axis. We will go up 1, but we do have a negative, so that means we will be in this quadrant and that quadrant. We want factors that give us 4, so we're going to go over 1, up 4. This one you can actually go 2 and 2, and then you can go 4 and 1. So that's cool. A little extra point, but all you really need is just 2 of them. Okay, but having, oops, right here, having 3 is a little helpful, especially the larger the number. Okay, there we go. That's the negative version. All right, we're at the 10-minute mark. That's totally fine. Here, I'm just looking for the vertical asymptote. Well, look no further than that. The number that'll give me 0 is actually x equals 1. Sometimes the SAT will just ask for the vertical asymptote, and that would be a simple question. Here, a positive 2 will give me a division by 0, so therefore that's why we have the asymptote. So positive 2 would give us 0, and that would be D. All right, first page.